Hi everybody, welcome to 76 Ground School Chick. Today I'm going to cover this preliminary report by the TSB of Canada about the Delta crash in Toronto. This report came out about a week and a half ago, and you've probably seen coverage in other aviation channels. But in this video, we're going to read through the actual TSB preliminary report. As we go, I'll pause to explain the human factors, technical breakdowns, and operational risks, including wind shear, visual illusions, crew pairing, and CRM. If you're a pilot or a student, or you're just really interested in aviation safety, this is the deep dive you've been waiting for. So let's talk about what a preliminary report is. It outlines verified and factual information at the time of the publication. It does not assign blame or identify causes. The aircraft was a CRJ Regional Jet Series 900 at Toronto Lester B. Pearson International Airport, CYYZ, in Ontario, and it happened on the 17th of February 2025. At 12:47 Eastern Standard Time, which is local time, the aircraft departed Minneapolis, KMSP, as Flight 4819, headed to Toronto International, CYYZ, with 2 flight crew members, 2 cabin crew members, and 76 passengers on board. The captain was pilot monitoring, and the first officer was pilot flying. In airline operations, flight duties are divided between 2 roles: the pilot flying, PF, and the pilot monitoring, PM. These roles are assigned at the beginning of the flight, and they remain in place during each phase. In this flight, the first officer was the pilot flying, and the captain was the pilot monitoring. Here's what those roles involve and why they matter. In a 2-pilot flying operation, duties are divided between pilot flying, in this case, the first officer. Those duties include: that pilot actively controls the aircraft, manipulates the yoke, rudder pedals, and thrust levers unless under autopilot, manages the flight path, follows the flight director, adjusts for weather and terrain and traffic, executes checklists and callouts related to the handling of the aircraft, responds to abnormal situations such as wind shear, unstable approach, with direct control inputs. The pilot monitoring, in this case, the captain, monitors the aircraft's flight path and energy state, cross-checks speed, descent rate, altitude, and attitude, reads and responds to checklists, manages radio communications with air traffic control, calls out deviations from approach stability criteria or aircraft parameters such as sink rate or go-around, backs up situational awareness, and intervenes if safety is compromised, including taking control of the aircraft if necessary. The flight was uneventful, and the crew received clearance for the ILS approach to runway 23 at CYYZ. The landing reference speed, VREF, for the approach was 139 knots. VREF stands for reference landing speed, and it's the target speed used on final approach for landing. There's a whole formula used to calculate it, but it depends on the aircraft weight at the time of the landing, the flap setting, the aircraft configuration, like gear position, anti-ice settings, and any MEL or minimum equipment list items, and also the performance data from the manufacturer. All of those are used to calculate VREF. Now, these specific parameters are determined by each company. According to Endeavour's company flight manual, final approach is flown at VREF plus 5 knots. When operating in gusty wind conditions, increase VREF by half of the gust factor, not to exceed 10 knots indicated airspeed. I find it interesting that Endeavour's procedures specify a maximum of 10 knots added, because these wind additives are designed to mitigate the risks from having a wind gust come and increase your performance and then suddenly go away and leave you without that increased lift and performance. The company that I used to work for used to allow up to VREF plus 20 depending on the conditions, so I don't know very much about the specifics of Endeavour Air's standard operating procedures, but in their case, this is what they were instructed to do. So in case you don't know what the gust factor is, that is the difference between the peak wind gust and the steady state wind speed. So if you have a steady state wind of 20 and wind gusting up to 30, the gust factor is 10. It's that difference. And then half of the gust factor is 5 knots. On the occurrence flight, the flight crew set the speed bug to VREF plus 5 knots or 144 knots. Given the reported wind gusts, the approach was flown at 149 knots. At 14:12:01, the aircraft descended through 500 feet AGL or above ground level. The aircraft's indicated airspeed was 150 knots. Its ground speed was 121 knots. So this shows that there was a decent headwind, and the engine thrust was indicating approximately 64% N1. N1 is your primary engine indicator. The rate of descent was 720 feet per minute, which is a good stable descent rate, and the localizer and glide slope were centered. 5 seconds later, the pilot flying disconnected the autopilot. All sounds pretty standard and normal so far. I think this is a good moment to address what the stabilized approach criteria typically include, and that is that the aircraft is on a correct glide path and course, that airspeed is within plus 10 minus 5 knots of the target speed like VREF plus additives, that the rate of descent is equal to or less than 1,000 feet per minute, that the aircraft is in the correct landing configuration, gear down, the flap setting, power setting is appropriate for the approach, all checklists are completed, and the approach must be stabilized by 1,000 feet AGL in IMC or instrument conditions, like if they're in the clouds, or 500 feet AGL in visual conditions. At 14:12:26 seconds, while the aircraft was descending through 175 feet AGL, its indicated airspeed was 144 knots, with a ground speed of 121 knots, and a rate of descent of 672 feet per minute. The thrust remained at approximately 64% N1. At 14:12:30 seconds, while aircraft was descending through 153 feet AGL, its indicated airspeed increased to 154 knots, whereas the ground speed did not change appreciably, consistent with a performance increasing wind gust, or a wind gust that's coming from the front. The pilot flying pulled back the thrust levers, and as a result, over the following 5 seconds, N1 decreased from 64% to approximately 43%, where it remained until touchdown. Now this is where the problem actually is, because the gust increased the performance and the natural reaction of a pilot is to pull back the thrust, but it remained there until touchdown. And so once the wind gust went away, it takes all the lift and the extra performance away with it. And that increases your rate of descent. And that's something you don't want when you're about to touch down, because as we went over the stabilized approach criteria, you don't want your descent rate to be more than 1,000 feet per minute. The airspeed began to decrease. At 14:12:40 seconds, 3.6 seconds before touchdown, when the aircraft was at a height of 50 feet AGL, the indicated airspeed was 145 knots, and the ground speed was 112 knots. The rate of descent had increased to 1,114 feet per minute. The Enhanced Ground Proximity Warning System, or EGPWIS, Oral Alert 50 sounded to indicate the aircraft was 50 feet AGL, which is a standard call-out. Remember that at this point their target airspeed was 149 knots and their target descent rate should be no more than 1,000 feet per minute. 1 second later, the EGPWIS alert sync rate sounded, indicating a high rate of descent. The aircraft's indicated airspeed was 136 knots, and its ground speed 111 knots, and the rate of descent had remained at about 1,100 feet per minute. The bank angle increased to 4.7 degrees right bank. The engine thrust was steady at 43% N1, which is just slightly above idle power. At 14:12:42 seconds, or 1.6 seconds before touchdown, the aircraft's indicated airspeed was 136 knots. Quite slow when their target is around 150, 149, and its ground speed was 111 knots. The aircraft was slightly below the glide slope, but on the visual segment of the approach and tracking runway centerline. The rate of descent, however, had increased to 1,072 feet per minute, and the bank angle was 5.9 degrees to the right. So this required a bump in power, because power is how you arrest the descent rate, along with pitch a little bit, but it required a bump in power. Less than 1 second before touchdown, the aircraft's indicated airspeed had reduced to 134 knots, and its ground speed was 111 knots, with a bank angle of 7.1 degrees to the right, and the pitch attitude was 1 degree nose up. The rate of descent was recorded as 1,110 feet per minute. Now, normally when you're landing, your bank angle should be 0 to half a degree, and your pitch angle during flare should be 2 to 3 degrees nose up. So there was not enough flare and too much bank, which also reduces some of that vertical lift. At 14:12:43 seconds, the right main landing gear contacted the runway. The aircraft was in a 7.5 degree bank to the right, with 1 degree of nose-up pitch, 3 Gs of vertical acceleration, at a descent rate of approximately 1,098 feet per minute. Typical G-forces are between 1.2 and 1.5 for a regular landing, and you can intentionally increase them to around 1.6 to 2 Gs if you want to have a firm landing to increase braking action in certain weather conditions. But 3G is definitely a hard landing. So this is where I want to address a couple things about optical illusions during landing. The first one is they were landing here on runway 23, which we can see right here in ForeFlight, and you can see that it is 200 feet wide. Now, the report said that the snow had been plowed to 160 feet wide. This is a runway that the first officer was used to flying into, and she was used to seeing it 200 feet wide. Now, when you have a narrow runway, it creates an optical illusion that you are higher than you are. So, especially given that she had flown to this airport recently, and she was familiar with the 200-foot width of the runway, I think it may be possible that she was also suffering from some type of optical illusion where she thought that she was higher than she was, which prevented her from flaring at the right time. The other optical illusion that I want to talk about here is blowing snow. The movement of snow across the runway surface can create a visual illusion of motion that conflicts with the aircraft's actual motion, tricking the pilot's brain in several ways. And I think 2 of those ways are particularly relevant in this case. One of them is the misjudged rate of closure, because blowing snow across the ground reduces the contrast between the runway and the surrounding terrain. The motion of the snow can make it feel like the aircraft is moving slower than it actually is, potentially causing a pilot to descend too fast or flare too late. Sound familiar? And the other relevant effect is the vection illusion. Pilots may experience a phenomenon known as vection, the illusion of self-motion caused by a moving visual field. So, when snow drifts across the field of view, the pilot may feel like the aircraft is banking or turning, even if it's flying straight and level. These sound like things that may have affected the final approach of this aircraft. During the approach to runway 23 at Toronto, the winds were reported at 270 degrees at 28 knots, gusting to 35 knots. With the runway's magnetic heading of 237, this created a crosswind component of approximately 18 to 22 knots. While this is likely within the aircraft and crew limitations, it was a significant crosswind, compounded surrounded by gusts and blowing snow. These conditions increase pilot workload and can make maintaining a stable approach more challenging, especially in the final seconds before touchdown. Touchdown, the following occurred. The side stay that is attached to the right main landing gear fractured. The side stay is a structural brace that keeps the gear locked down. The landing gear folded into the retracted position, the wing root fractured between the fuselage and the landing gear, and the wing detached from the fuselage, releasing a cloud of jet fuel which caught fire. The fuselage slid down runway 23, rolling to the right until it became inverted because the left wing was still attached and still creating lift. A large portion of the tail, including most of the vertical stabilizer and the entire horizontal stabilizer, became detached during the roll. The aircraft went off to the right side of the runway into the snow-covered grass area and came to rest on runway 15 left near the intersection with runway 23, about 75 feet beyond the right edge of runway 23. Figure 1. So, about the crew. The captain had worked for Endeavour Air since 2007, has an airline transport pilot certificate issued by the FAA. He's employed as a flight crew member and a simulator instructor. At the time of the occurrence, he had accumulated about 3,570 hours total flight time, including 764 hours on the aircraft type. In the previous 7 days, the captain had worked 3 days as an instructor, I'm assuming in the simulator since he is a simulator instructor. He had flown 3.5 hours in the previous 30 days. That's not a lot of hours for 30 days. The first officer has worked at Endeavour since 2024, holds an airline transport pilot certificate issued by the FAA. At the time of the occurrence, she had accumulated 1,422.3 hours total flight time, including 418.7 hours on this aircraft type. I'm assuming that it doesn't say here, but that she has a restricted ATP because of the amount of hours, since 1,500 hours are required for the unrestricted ATP. Over the previous 30 days, she had conducted 3 round-trip flights in and out of CYYZ, not including the occurrence flight. So she was quite used to this route. She had flown 56.3 hours in the previous 30 days. So a lot more than the 3.5 hours of the captain. She was actually a lot more current, which brings me to something else that I want to talk about here. Airlines often use, and my old airline used to use, something called the crew pairing system or the crew complement scoring. So how it works is experience levels and point systems. Each pilot, captain, and first officer, and sometimes flight attendants or relief officers, depending on the operations, are given a numerical value based on their experience level. For example, a highly experienced captain might have a score of 5, whereas a newly upgraded captain or a less experienced first officer might have a score of 2 or 3. And the airline sets a minimum combined score that the crew has to meet. For instance, an airline might require a minimum score of 7 for the flight deck crew. If a new captain is scheduled, they must be paired with a highly experienced first officer, for example. The purpose is for safety. It prevents situations where 2 inexperienced pilots are paired together, and it ensures that at least one pilot has significant experience handling emergencies, complex airspace, or challenging weather conditions. So this brings up a couple questions for me. Does this airline use the crew pairing system? And if they do, did the pairing meet the minimum criteria, but then was it not truly balanced? So everything that went wrong happened really close to the ground and really quickly. But I do have questions like the pilot monitoring must call out deviations assertively and the pilot flying must respond. But no power was reapplied and there was no go-around executed. This was probably because there was no time and they were too close to the ground, but it would be interesting to see what the rest of the investigation finds. Once the aircraft came to a stop, an evacuation began. All occupants evacuated the aircraft. It has been confirmed that 21 of the 80 occupants were injured. 2 of those occupants were reported to have serious injuries, but thankfully no fatalities. The crew escaped through this hatch right here, and the aircraft rescue and firefighting personnel arrived approximately 5 minutes after the accident. A passenger attempted to use the forward emergency overwing exit located on the starboard side of the fuselage at seat 12D. However, because the fuel was flowing over that exit door, most rear fuselage occupants evacuated via the overwing exit door at seat 13D, some of whom got covered in fuel. Several passengers exiting through the same exit were also sprayed by fire retardant foam from the ARF, or Aircraft Rescue and Firefighting Vehicle. This highlights the importance of egress training, spatial awareness, and the work of the flight attendants, as well as teamwork. This crash was survivable thanks to strong crew coordination during the evacuation. But the approach and landing sequence raises important questions about how we train for wind shear, how visual illusions are briefed, and how experience is balanced in the cockpit. I'd love to hear your thoughts. Should recency matter more than total time in crew pairing? Should wind shear be a more prominent part of scenario-based training? Let me know in the comments. And if you found this deep dive useful or valuable, please remember to like, subscribe, and consider joining the channel as a member. Thanks for watching, and see you in the next video.